Hey, dear friends, welcome to the Python for Security series. In this series, we'll be surrounding how to utilize the Python. This is very powerful and easy to use programming language to create our own exploits or our own tools. For example, like networking tool. And I will assume that you have a very basic knowledge of Python already. For example, how to install the Python interpreter in your machine like Kali Linux or any other machines. Also, how to install IDE environment. For example, like code, what I'm using now. And enough said, let's just get started today's video, which will be creating our own TCP server. And the major module, of course, for Python, the power of the Python, we can utilize available modules, inbuilt module or the third-party modules. In this episode, or for the tool of the TCP server, what we are trying to create is socket, and we can import socket module. And the next one is threading. The threading module can allow us to run multiple tasks at the same time. And in this case, we will set up the server, the TCP server, and by threading, we can allow to accept and process requests from different or several clients at the same time. Okay, the next one is sys. I'd like to use sys module to capture the user inputs. Of course, also we can use other modules, similar modules like OPT pass. Anyway, now we just let's just go to the code part. And I think I will use the OOP or object-oriented programming methodology to create this tool. In my personal view, this is more efficient than the traditional way. Okay, so we can use class to define our own class, and the name is, of course, based on the PP specification. The class name should start from the capital letter. My TCP server, like that. And inside the class, we have to define like attributes and also the methods. The first method always, will be init method. Here we can do some initialization. For example, can assign the value to the attribute, or do some introductory actions. Next, we can define the ROM. And the parameter name always we can use the self. Of course, you can use other name, but as tradition, we always use the self so other people can understand what it's about. Okay. First, we need to capture user inputs, and then we need to make judgment whether the user has already specified the port number. So we can use if and len sys aegv. And if the length is shorter than 2, it means that the user doesn't specify the command correctly. So we can print like example usage, and we can use the string %s as our pressure and port number, and the sys, the first element is our program name or file name, right? And we can exit from the program. If the user has already supplied the argument properly, then we can save that input or value into the port number, and we can sys. All right, and we need to translate the string from string to integer. But we need to use the try to capture exception, because sometimes the user input some wrong type of data. So we can use the try. And if there is any type of error, we can just print some error message to the user. Please use integer as port number, right? And then we can exit from the program. We need to, I think the port number should be our attribute of this class or object. So we need to use the self. Self means this means the object or instance of our class, okay? And if everything is going well, next we need to set up the listener, because we are TCP server. Also, similarly, we can use the try to capture any exception as E. The error message will be stored in E variable, and then we can print something is wrong, and then we can exit from the program. All right. Next, we need to, similarly, of course, this should be the attribute of object of this class, the myTCP server class. And the attribute name is server socket. And we can use the socket and the socket method to create the object of the socket class. So, socket itself is so complicated, but by utilizing the module socket, we do not need to care about the details. We just use the interface provided by the socket module. And of course, we need to specify the IP address type, which should be init, which means IP4, v4, and the socket. And of course, we need to set up, what we need to set up is TCP server sock stream. Okay? And then we can we can assign the IP address and port number to this object or instance server. A bind. The code can give us the help how to use this method. And the address should be tuple, and we can use any IP address available on our own machine. And also we need to give the port number. And I'd like set another option in case we do not want to have error. For example, like which kind of error? You close down the program or interrupt, and if you want to run it again, and will give us the error. The port number or address is already used by somebody else. Of course, I don't want such error, and so we can use the self socket and can set sock opt and socket sol socket and socket and the reuse. I can use the find to be 1. Yeah, this one. Yeah, we have this line to avoid the error what I mentioned. Okay. Yeah, we have already assigned the IP address and the port number to our socket, our own socket instance. Next, we need to start the listening, right, server. And we can accept up to 5 collections at the same time. Okay. Of course, also we can print some message for the user if you wish. The server starts listening on port, and we can put self port number. Okay. So of course, for the debugging, such a message would be useful. Okay. So I think in the init method, we have already done all different jobs. Next, we need to let our server to do the job. For example, like accept the request from the collection from the client and process such request or collection, right? And of course, our TCP server will run. Yeah, we can process requests from different clients, so we can put all codes into the while loop. True. And then we can use the self server socket and use accept method. And from here we can know, yeah, this method will return 2 things. Yeah, 2 objects. The first one is new socket. We can name it to the client socket, and also will return the client address. All right. Next, we can utilize the threading module to process the request for each individual client. So we can use the T and the thread, set up the threading object, and we can use the target. And the target, we can configure configure the tasks which will be processed by the target function. For example, here, self client handler. Of course, at this moment, we didn't make this method. And also we can give some arguments like a client socket and client address. So these arguments will be passed into this function or method at the same time. And then we can start this object. Okay. Now we need to write the client handler. And this, of course, the first parameter always will be self. And the second one would be client socket, client address. Okay. Next, of course, also we want to put all tasks or actions into the loop. And we can capture data supplied by user. And we can put some banner in front of our input data, for example, like S and the dollar. Maybe I can use a space. I think this would be much better. And then we can client address. Yes. Of course, we need to convert the tuple to the string, and then can be printed out. All right. And if input data equal to Q, it means that the user want to exit, from the target or client session. So we just use a break to quit from this loop. Next, we need to send the data. Of course, for this code, I will not implement a complicated function. We just want to exchange text message, send and receive a message. But in the future, we will write more complicated code. Okay, so please make sure follow my videos. Okay, now we can use the client socket and send. And of course, for the Python 3, we need to encode before sending the data. Encode UTF-8. And of course, I'd like to add the line separator. I think this would be much better. Then we can wait, the client to reply, and we can use receive data, and we can use client socket and receive, and we can put the buffer to 34096. All right. And then, of course, this data is encoded in UTF. And then we can print out the data. All right. I think I have already done everything. It's okay. We need to test this code. We can use if lim and we can create the object from class my TCP server class. So it will be my TCP server, and then we can run. This object will have all attributes and also the methods of this class. So we just use the method run. Okay. Of course, if you import our code into other files as a module, and this line below will not be executed or run. I think you know this, right? So I just save and test this our own TCP server. Python my TCP server, and we need to specify the port number. It looks like it's working. And next, I'd like to use the netcat as our client. Okay. Then we can send a message, for example, like JSON. We received. And also we can send back or reply back. Hi. All right. Get hi from the client. And now we can run, for example, we want to exit from the program. Q. I think we need to do some more things. We need to we need to capture the keyboard interruption. Except keyboard. So if the user press Control and C, and this will tell the program to exit. So we can print like exit from the program now. And also then we can cease. Before we exit, we need to close our server socket, self server, close, and then can exit. Also here, if we run out of the loop, we need to close down the client socket, close. All right. Let's run it again. We can send a message. Hi. No problem. Hello. No problem. Then if we want to exit, we just Q. Input Q. Now the client has already exited or interrupted. But here our server is still running. And if you want to exit this program entirely with just Control and C, this will capture such exception. And as you can see here, and will close down the server socket and then exit the program. Okay, so that's pretty much it. In this episode, I show you how to create our own TCP server, which is so wonderful, right? Of course, you can customize the code as you want. Okay, see you in the next one. Bye.